So my name is Tom Crane. I'm the Technology Director of Digerati. We're a company based in London and Glasgow in the UK. But I'm here today because I'm also one of the editors of the IIIF specifications. And I'm also co-chair of the IIIF AV Technical Specification Group. So if there are any AV related questions, we can get to them at the end. So I'll just dive straight in. What is IIIF? So I guess a bit of background. People have been digitizing collections for the last 20 years or even more. And over that time, thousands and thousands of little sites and small collections have been digitized and put online. So, for example, here's a page from the Bodleian Library with dozens and dozens of independently financed and digitized and delivered small collections. And what typically happens is that a collection is digitized, a grant is awarded for that digitization, and a lovely site is built, beautiful site, but it then gets kind of stuck in the technology of its time, and then ends up basically in a silo. Now, all these things have very often common themes. If we digitize books or manuscripts, we present them in book readers or image viewers. Often there's a deep zoom component, so we can zoom right in and look at the detail in a painting, for example. Often there are transcriptions, OCR, full text available. Maybe there's a kind of accompanying text to read when we digitize a book. Sometimes these digitized objects are available for annotation and commentary and additional content creation. They're often linked to other objects so that references in one text can link across to another digital object somewhere else. So what we've been building up till now, or up till a few years ago, is a sequence of silos. All of these beautiful, wonderful digitized collections are not interoperable with each other. They can't, we can't reuse the same tools, the same viewers, the same annotation tools. We can't pull content out of one collection and compare it with content in another because they're all in their own individual silos. So what IIIF, the International Image Interoperability Framework, attempts to do is provide a standard to take care of those silos, to break that digitized content out of those silos. And I'm just going to go through some use cases that IIIF addresses. So if you imagine that I'm visiting Stanford's digital library and I'm doing a search for celestial maps, and I come up with a few objects. Because they're IIIF, I can Stanford's viewer and view them and compare them in a standalone viewer. But I can also pay a visit to Digital Bodleian and see if they have a celestial map. So I've searched for celestial map. I find one in the catalogue. I notice that this object is also available at IIIF, and that allows me to take it from Digital Bodleian's environment back into my IIIF compatible environment where I'm looking at objects from Stanford and view them side by side, compare them, and so on. So it kind of standardizes my ability to pull digital objects from different locations, different institutions, and do things with them that maybe the publishers of those digital objects hadn't foreseen. So object comparison is one use case. Another use case would be having a common format for digital objects so that when we want to do interesting and complex annotation projects on them, such as this one from the National Library of Wales, we don't need to kind of invent new ways of reading the source formats of objects, and we don't need to invent new ways of describing the association of the data we're capturing with those objects. We can standardize the kind of inputs and outputs to, say, a crowdsourcing project around IIIF, and then reuse the components we build for these crowdsourcing projects on different collections, gathering different data from users, asking for different information. You can see here we're kind of building forms and we're capturing regions of images. This is a classic IIIF use case. So, so that kind of object comparison, annotation, building complex applications on top of digitized objects, these are all IIIF use cases. But so are simpler use cases like reading a book. So here is one of the first IIIF viewers. This is the universal viewer demonstrating some content from the Wellcome Library. This is available as IIIF, and it allows us to construct those kinds of familiar book reading experiences, and also a standardized way of searching. So this object not only has its images available, but has its full text available, and I can search that full text because the server at Wellcome implements the IIIF search API. And so anyone can use this viewer against any repository that implements that API, and they get searchable content. So how did this come about? So IIIF is a consortium of currently about 60 institutions, but has many other institutional participants who aren't consortium members. Most European national libraries, and in the UK, the British Library, National Library of Wales, and the National Library of Scotland are all consortium members. But other university libraries, especially in the States, research libraries, also museums and archives are more and more coming on board with IIIF. And in order to make this work, that consortium shepherds the specifying of a set of APIs and specifications to make all this work. So how do they do that? Take a step back and consider how we might go about solving this problem. So if we think about visiting a library, there are two kinds of interactions we can have. We can interact with the descriptive metadata of the library, which is the usual subject of most APIs in the cultural heritage sector. Now, that API may not look much like the image on the left anymore, but essentially, that's the descriptive metadata. It lives in the catalog. But the objects themselves, the books or the museum objects or the archival items or the manuscripts or whatever, they are physical objects in the world. And although the organization of those objects in a space might be influenced by the descriptive metadata schemes in use, you don't actually need those descriptive metadata schemes to interact with that object. If I want to pick up a book and hold it, I understand what it is because I'm a human and I've seen books before. So here, for example, is a mark record for an object, a computer readable description of an object, and then there's the object itself. The standard on the left, in this case mark, is one particular standard used in a variety of ways in one particular domain. In other domains, say for example, if here's an archival item where quite different metadata standards and approaches are used. But in both cases, we have a description on one side and a real world physical object on the other. So how would we go about making a standard that allows us to convey those real world physical objects? Because there are so many kinds of descriptive metadata schemes that we could have on the left. So we might start to think, well, we're going to need to describe who created it and what the materials are and what it looks like and all sorts of other interesting things, but we're going to run into lots of problems if we attempt to kind of describe any possible cultural heritage digital object using descriptive schemes. In fact, all we're interested in and all IIIF focuses on is the notion of a standardized format for a digital surrogate. Because when we interact with a digital surrogate on screen, we still have our human cultural awareness to interact with it. So we don't need, although we might see the results of a descriptive metadata scheme, we don't actually need that to interact with the object and turn its pages or look at the brushstrokes in a painting or look at the detail of a film. So the standard doesn't have to concern itself with descriptive metadata schemes that exist. It needs to concern itself with the presentation of that object. Because unlike us visiting a library and picking up a book, machines and the web need some assistance in conveying and reconstructing that experience for us. So what IIIF does is mediate this viewing experience so that we can look at books and archival objects that may be very complex, or manuscripts that may have some structure. So on the left here, we have some structural information about the parts of this manuscript, or even objects that don't fit easily into category, this Bovril commemorative coin. So just to kind of recap a second, What IIIF does is concern itself only with presentation. So I'm just going to show you a slide here that has on one side the particular descriptive metadata model of one institution on the left, and on the right hand side the world of IIIF. And what's happening on the left is the metadata about this object, about this thing, and what IIIF concerns itself with on the other side of this wall is the content of the object and content that has been applied to the object. So the content of the object is things like images, text, binary content, audio, video, images, and text. And content on the object are things like commentary, annotations that link, and so on. That's the domain of IIIF, this digital space for assembling and presenting the object and sharing it in a common format. IIIF does not attempt to do anything on the left-hand side of this diagram. So you can replace what's happening on the left-hand side of the diagram with whatever descriptive metadata scheme you like to use, but what happens on the right-hand side is the world of IIIF. And what the intention of that is that we can bring as many different kinds of viewing experiences to those objects as our creativity allows. So here we see that same document from the Wellcome Library being viewed in 8 different viewers. From, there's the universal viewer in the middle, Mirador is another IIIF viewer in the bottom left-hand side, which is able to show the text. In the bottom right-hand side, we see that same object, that same IIIF object being served from the Wellcome Library, being rendered in a viewer that plasters it over the walls of a virtual gallery you can walk through. These are all potential ways of reusing IIIF content, but we've standardized the description of the digital object without being opinionated about the descriptive metadata that may accompany it or may link to it. And this allows us to build all sorts of other interesting applications that meet all sorts of interesting use cases, such as crowdsourcing applications, book readers that allow us access to the text, video applications that allow us to access to transcriptions, content creation tools, search. So, because all these things are potentially available and all the content associated with them is potentially available in this digital space, this common scheme, we can bring tools and applications to that content and search it and interact with it. So Dave Allen asks, is the UV searching PDF OCR layer? The answer to that is no, but I will get on to that a bit later if that's okay. So how do we do this? Well, two specifications, APIs at the core of IIIF, and what we're going to look at today is the presentation API. This is just enough metadata to drive a remote viewing experience. So as I said, it's not the descriptive metadata, it sits alongside the descriptive metadata. Typically there's going to be a link from the descriptive metadata to the IIIF representation, and almost ideally a link from the IIIF representation to some descriptive metadata about the object. And the descriptive metadata, as we've looked at, isn't the thing that gives us access to the content of or on the object. It doesn't help us read the book. It helps us understand what the book is, but it doesn't help us read it on screen. So what IIIF does, accompanying descriptive schemes, is provide a model for describing digital representations of objects, but crucially, a format. IIIF is playable. I go to the Wellcome Library or the British Library, I fetch a IIIF resource. It's a playable resource. If I load that into a viewer or an annotation tool or some other piece of software, it understands that and can render it. And then this third point, the IIIF model describes or defines a shared abstract space and time for the content to be assembled. Now that's a bit of a mysterious statement, so I'm going to dive into that a bit more and hopefully will explain some of how text is searched in that space. So the kind of secret behind IIIF is that it's really one particular assembly of simple web standards and existing other specifications. And there are two foundations for IIIF. One is called Shared Canvas, which gives us content assembly space. And one is Web Annotation Data Model, which is a new W3C specification. Well, it's been around for a while, but is now a formal technical recommendation from the W3C, which means it's at the same level as things like HTML and CSS. And these are the two foundational standards on which IIIF is built. Shared Canvas gives us our interoperable space for assembling content, and the web annotation model is how we link content into that space. And fundamentally, this is a canvas. If we're considering IIIF for D objects such as book pages or paintings or manuscript pages or maps, then a canvas is basically a pair of numbers that just define a coordinate system for that object. So, for example, if this were a page of a book, it would have an aspect ratio that conforms to those two numbers. It gives us a space to assemble content. Here is a painting. So here is a canvas that represents the abstract space that painting occupies. It has a coordinate system, and we've applied two annotations to this canvas. We've assembled two pieces of content. One is a JPEG, an image of the painting itself, and one is a piece of commentary about a particular part of that painting. So this is a kind of the key content assembly concept in IIIF. Usually, if we think about annotations, we think of them as being things that we are adding on top of an image. So in this picture, conventionally, we would think there are two annotations in this picture. There's a comment about the illumination and maybe a transcription of the text. But in the world of IIIF, that picture has three annotations: that canvas space, and then we are annotating onto that in assembling our content, an image, which is filling it in its entirety in this case, and we are adding an annotation to the canvas about a particular part that is a comment about the illumination, and we are adding another annotation to a particular part that is a transcription of that part. And this content assembly process gives us this shared interoperable IIIF space. So you can see here another example. Here is a piece of archival material. I've only showed three annotations that might exist for this. So in this case, you can see there's a particular line of text, or two lines of text, one printed and one handwritten, that have been identified as annotations. And we're providing the text for those regions of the canvas that way. Another annotation is a description of an image that's part of this canvas. And then the final annotation is an image itself to fill this canvas. And if this were, if this had been crowdsourced or OCR'd, we'd expect to see maybe 20 or 30 separate annotations on this canvas that provide all those pieces of printed and handwritten text. But essentially, what IIIF is doing is giving you this in a playable format. So we're looking at it in a very abstract way on screen, but what IIIF is doing is giving you that in a format that a browser-based application can play or render or deal with. So you can see here that this allows us to assemble multiple pieces of content on the same abstract space. We're not annotating an image directly. The image is itself one of the annotations. And one of the reasons we might want to do that is, say, we have a canvas that represents a page of a manuscript. One region of that canvas is the illumination or the text, and one annotation on that canvas is a transcript. But we might also have 10 or 20 separate image annotations that form a multispectral stack. So in that case, we're not assembling in, we don't have to choose one particular image as the kind of default image. We can say that all these images in their different wavelengths of light are part of the representation of this object. And moreover, we can have canvas space for which we don't have an image. So in this invented hypothetical example, I have a manuscript that has been torn up, and I have maybe at separate institutions different parts of this manuscript. Each of them has an image they can serve, and in IIIF space I can reassemble the parts of this manuscript. And maybe I don't have the fourth piece, but maybe I have a transcript of that piece because it was someone wrote down what it said a few years ago or a few hundred years ago, but we've lost the actual fragment. So we can still talk about things that don't actually exist because we have this abstract canvas space to talk about them in. And a real world example of that, I hope this video is all right, is a manuscript in one place in Paris and some illuminations that were cut from that manuscript that are held in another place, but we can recombine them digitally in IIIF. So what you're seeing here is a IIIF viewer that's viewing the manuscript with its holes, and what we can do is turn on another source of data that's the other institution that's serving the actual illuminations, and we can digitally recombine these two sources of data. If we looked at the network traffic here, we'd see images coming from two different locations, but in IIIF, through the mechanism of the canvas, we can recombine them in the way we're seeing here. Right, so we've seen here that we're dealing with a canvas. We're dealing with one page of a script in this case, but the typical unit of distribution of IIIF resources is a resource called a manifest. So when I load a IIIF resource in a viewer, I'm typically loading a resource called a manifest. And a manifest is basically a sequence of canvases. So if I had digitized a book, that has many pages, hence many views, hence many canvases, and my object that I publish and distribute, I provide an endpoint for. So in this case, you can see the URL of this book at the Wellcome Library. Its IIIF representation is a sequence of views, one view for each page. And a viewer, such as the universal viewer, would load this manifest from that address and render the sequence, in this case, rendering it as a book. So a manifest is essentially a sequence of these canvases. And it may be a sequence of just one canvas, if, say, the manifest represents a painting for which there's only one image, but it also may be a 1,000-page book, for example, in which case there would be 1,000 canvases. The other important thing that a manifest does is provide structure. So in this example, this is from the National Library of Wales, this object has a table of contents associated with it, because as well as a sequence of views, it has some structural information which allows us to navigate around, within, and across those separate views. So, if you digitized a book, you could you capture the structural information, its table of contents, for example. You can turn that into IIIF resources called ranges, which allow us in a viewer to reproduce structural navigation around the work. In the example we've just seen, that structure is typically a few pages per structural unit, per range, because they're book chapters, but that also applies, say, to newspaper articles. So again, this is National Library of Wales. This article, this particular part of a column of one page of newsprint, is a IIIF range within a manifest. So a range can apply across views or within views, for example, to pull out a particular column of newsprint or a particular article. And it can also be both. So, for example, you could have a range that described a newspaper article that began on one page, continued for 3 columns on the second page, and finished in the 4th column of the 3rd page. You could describe all those parts, all those fragments as one range, and you could associate the text of that range with the IIIF resource. And that's exactly what's driving this UI you're seeing here. So again, these are use cases that are familiar from existing projects and user experiences we're familiar with for collections. But what IIIF does is provide a common format for doing them in. So just to summarize that section briefly, the IIIF manifest is the unit of distribution. That's typically, if I email you to a IIIF object, I'm typically emailing you a manifest URL. And that manifest would contain a sequence of canvases, and the canvas is for content assembly. So when you're interacting with a IIIF resource, when you're viewing and zooming into it, or you're annotating it, a viewer is rendering a canvas to you. So by publishing canvases, if you're Wellcome Library or the British Library, you're publishing tens or actually hundreds of millions of canvases for your IIIF content, and you're publishing coordinate systems to the web for you and others to make statements about that object. So just to recap on this piece, you can see here the canvas, two annotations. One provides the image content that a viewer would display. One provides an annotation that maybe a more sophisticated viewer or annotation environment would display. And just to reinforce the point about shared space, here is an annotation use case. So here I've got a painting from the Wellcome Library, and I'm going to create a new fragment of IIIF space. I'm going to create an annotation on this resource right here in my annotation tool. Now, this isn't part of a crowdsourcing project. I'm just doing this as a demonstration. But what I end up with is a piece of, a fragment of the IIIF universe. And in this case, it's a piece of JSON data. So the exact details don't matter too much. But that fragment of code, that fragment of JSON data we see on the screen, is a newly created part of the IIIF universe that's linking my comment to a region of this painting. So I haven't saved it anywhere yet. It just exists on my clipboard right now. I could publish that to some central store, or I could submit it as part of a crowdsourcing project. But all I'm going to do for now is just take it somewhere else and paste it. And there's enough information in that little chunk of data to fetch the manifest that the canvas belongs to, find the canvas, draw the box, and show the text. This is a really simple example, but it just demonstrates that the fact that any institution that's publishing IIIF content, their content is available for this kind of reuse, recombination, sharing, citation, and so on. So here I've just created a little fragment. I created an annotation on that particular region, and I provided some text. As a human, I did that using a tool, but typically can do that at great scale when they OCR or transcribe the contents of digitized objects. So in this example, we can see that there are a number of annotations available on this canvas, and each of those rectangular blocks is an annotation that's providing the text description of that line. And in this case, the source of that content is a machine-driven process. It's OCR. And if I take away one of the annotations from this canvas, the image, I still have those textual annotations. That is just one part of that canvas. Another example of machines assisting us in creation of annotations is this example. So this is a project called the Indigenous Digital Archive. And in this project, natural language processing is being used to get annotations that tag people and dates and places and concepts in the text. And the purpose of this is to generate navigation around these works, and also to generate a vocabulary that human crowdsourcing volunteers can use to apply to parts of the archive that aren't quite so amenable to OCR. These are all annotations, but they can be created by humans or by machines. And just to get back to the search, so we saw that search being conducted earlier. What's going on behind the scenes in that search is that the text that's been captured during the OCR process is sitting in a search server. The client is submitting a query to the server. The viewer is submitting a query to the server. The server is doing a full text search in the same way that you might search any text content on the server. But it's being given the results back as a list of annotations. In this case, they're highlighting annotations that just allow the viewer to draw some highlight boxes around the occurrences of that term on the page. So not only are annotations, they're also used to return search results, because in this case, our text is coming back as things to highlight in the canvas. So, and it's all done through the same mechanism of annotation. Now, what exactly happens behind the scenes is implementation specific. So the Wellcome Libraries search service and the British Libraries search, or the National Library of Wales Libraries search, may be completely different implementations under the hood, but they're being conveyed back to the viewer via a standard, which in this case is the IIIF search API. I'm just going to summarize this section briefly. Essentially, when we publish IIIF, we're publishing a representation of our objects that is a sequence of one or more canvases, and a canvas is a coordinate system that we can assemble content in through annotation. And that assemblage is then published in a format that viewers, annotation tools, screen readers even, and other clients can understand and play. And what that does is give us the ability to generate all these different user experiences, all these different reuses of content. One institution can use the viewer developed by another institution. So for example, the Universal Viewer here was initially developed for the Wellcome Library and then developed for IIIF by the British Library and National Library of Wales and many others. Many institutions use it. Mirador, that's also on this page, is used by dozens and dozens of institutions as well. And people can collaborate and cooperate on developing new tools and new user experiences, and then they're available for reuse on that content. And similarly, crowdsourcing projects such as the National Library of Wales crowdsourcing project that we took a brief look at earlier can now benefit from the fact that the source material, if it's available as IIIF, doesn't need to be converted or uploaded to a crowdsourcing platform. It can just be registered and consumed directly. And the outputs of that effort can be saved as further annotations, additional content assembled in that space. So I'm just going to pause at that stage because that was the kind of first part. I'm just going to look at the questions in the chat. So Isabel asks, if we wanted to adopt IIIF, what happens with our current digital object management system? So increasingly, the community is reaching out to DAMS vendors and preservation system vendors and so on to ask them to implement IIIF. And a number already are doing that. That's one approach. Another approach is to have a IIIF specific environment alongside. So and this partly depends on the size of the institution, but typically the outputs of digitization workflows are not typically IIIF right now because those systems haven't yet adopted that, but they're typically transformed to IIIF. So just as an example, both the British Library and thousands others use METS as a format description for the output of digitization workflow. And typically the METS file is what's being transformed into the IIIF manifest. So there's a question about IIIF version 3. Do we need another server with a different image version to be managed by IIIF 3? Not necessarily, because I think what will happen with servers, so this is what's providing the deep zoom and the ability to request a particular region of an image. I think image servers will port to version 2 and version 3 alongside. That seems like a reasonable thing to do. So there's a good question here. Given the amount of digitized content that is currently siloed in repositories, digital humanities projects, etc., is there a roadmap or list of requirements that you could reference to help custodians prepare for the transition to IIIF? That's That's a really good suggestion. As far as I know, and I may be wrong here, I mean, there are lots of training resources for IIIF and lots of implementation examples. There is a list called IIIF Awesome, which if you Google that, you will find a list of software implementations. But as far as I know, there isn't a kind of roadmap checklist for, I have digital objects in a silo, what's my best strategy for getting them into IIIF? I mean, that may be very collection specific, but that would be, yeah, I'll take that on board and see if anyone has got that. So the BL Technology Training Room, I think that's the correct source. Says, can you say something more about IIIF manifests and why we have different flavors? I'm assuming this question refers to there's two different versions kind of out there in the wild of IIIF. There's the current version, presentation 2, which has widespread adoption, and there is the beta version for the next version of IIIF called presentation 3, which I can actually introduce in a second, because that new version is what allows IIIF to deal with AV material as well. Are there any stats on the performance of IIIF APIs? I might have to come back to that one at the end. I'm just going to, that's a good point to just introduce what presentation 3 is. So, yes, so far we've been looking at images, but the new version of IIIF that the British Library especially are doing lots of work in, it supports time-based media as well. And really the motivation is for this, can we do all that we've just seen for time-based media with the same mechanisms, the same annotation mechanisms, and the same interoperability, and the same kind of searching and additional information? Well, at the moment, just to recap, we assemble our content onto a two-dimensional canvas, and that might be images and text. But the world of AV has an avalanche of use cases, and some of these in the British Library. If we want to model things like the White Album or the British Library's Sound Archive, or many other sources of AV content, such as Lou Reed's tapes, or field recordings, or albums, we have a lot of work to do. And similarly for movies. So here's a use case from the BFI, a reconstruction of the film Napoleon, which has multiple projections, multiple sources of film, multiple sources of sound. Can we do on our canvas for time-based media what we've just seen happen for two-dimensional and text-based content? Well, in one sense, we can already do this because we can apply a piece of film to our canvas. We can say that this film is a part of content of this canvas as well, but we can't say it occupies a particular time segment of that canvas because this canvas just has time. So the simple answer to this, and the simple answer is a good answer, is to add the time dimension to the canvas so that as well as a width and a height, a canvas can also have a duration. And for audio only materials, a canvas can have just a duration, so have no width and height. So if it's for example, a radio broadcast, the canvas has just a duration. It's just an extent of time into which content is assembled. So more to presentation 3 than that, but essentially that's the biggest difference at the heart of it. And then there's a whole load of use cases that spin off out of the fact that now canvases can have a time dimension. What we want to do is make the kind of commonest use case, the kind of 99% use case where you have one time-based, one piece of AV material annotating one canvas. That's just as easy, but we need all the other complex stuff to accommodate the various use cases that we see out there in the wild. Just to reinforce the fact we can now assemble content in space and time. Now I'm going to try something now that requires audio, so we will see what. So this example is a So what was happening there? Well, this viewer, well, it's not really a viewer, it's a player, is playing, in this case, a time-only canvas, a canvas with one time dimension only and no spatial dimensions. And into that time dimension are annotated an MP3 filling the time dimension with the sound content, but also text transcript. And I'm hoping this one will demonstrate what's happening here. So you don't really need to see the details of this, but we can see here that this annotations include an MP3 that annotates the whole canvas. So just as we were seeing fragments of text annotating spatial regions of the canvas, we see here fragments of text annotating the temporal extents of the canvas. But the mechanism is identical. It's just the targets are time fragments rather than spatial fragments. We can have both. So in this example, we have a canvas and we have two pieces of video annotated onto it at the moment. And they're targeting both different spatial regions and temporal regions. And we've just flipped over to a point where one of the pieces of video stops and another one continues. That's annotating both a different spatial and temporal region. And just a kind of more real world example of this, here we see an example that has both text, audio, video, and images annotated into different time and spatial regions of the same canvas. So that's an example of the canvas being extended to space and time. Now, in the same way that we saw structure being applied to newspaper articles or book chapters, we can apply exactly the same mechanism to structure that targets time extents rather than spatial extents. So here is an archival object from the British Library. It represents 2 hours of broadcast Radio 4. It starts just a few seconds into the loose ends program and then continues for another 2 hours across two sides of tape. And the modeling decision used here is to have one canvas for each side of tape, because that represents kind of view. But the logical structure of this object is spread across those pieces of tape. In fact, there's a program, Saturday Review, which starts on one side of tape, therefore on one canvas, and finishes on the other side of tape, but out of which we might want to construct a continuous listening experience. And so that's what's happening in this example, which I will attempt to talk over. Here is the universal viewer playing some sound content from the British Library. And in this view, we're seeing the one particular program. But if we pop the universal viewer into its more conventional mode, we can see the whole 2 hours of tape, and we can see our different parts of the object using ranges. So it's exactly the same user experience, but the structural information is being applied to time. And just another example. Again, we're seeing ranges being used to apply to different regions. And now we're seeing exactly the same content in another viewer. And this one also is displaying textual annotations because there is transcription annotation available to it. And we can take that one step further. Here is an example of German parliamentary debates. And We, and what we're seeing there is a canvas on the left-hand side with a video, but also the annotations that target particular time fragments running alongside, just targeting phrase length extents of that same canvas. And when reconstructed in the viewing experience, we're dealing with line-by-line transcriptions, we're dealing with phrase-by-phrase transcriptions. This is really fundamentally exactly the same kind of idea as providing the text transcriptions of a book. So here I have a book, and I'm able to pull out those IIIF annotations and display the text alongside, and I can do that for any book. So this is a book from the Wellcome Library, and I'm just viewing in detail each line of text from the book, because that's available as an annotation that allows me to access where that is on the canvas. I can reconstruct those things into a viewing experience. But under the hood, so what we're seeing here is at the top, an annotation from the German Parliamentary Archives with a phrase, and at the bottom, an annotation that's a line of text from that book. The only real difference between them is the target. In one case, it's a time fragment, and in another case, it's a spatial fragment of the canvas. So what we've done with presentation 3 is kept exactly the same model, exactly the same content assembly model, the same annotation model, the same interoperability, the same kind of search mechanisms, but just extended the shared space that our digital objects can exist in to the time. And that allows us to assemble both 2D content and time-based content in the same space. And I'm going to switch back to the chat now. Okay. Because I guess the most obvious question there that would follow that is, what about 3D objects? So that's a question that comes up a lot. And there is a 3D interest group in IIIF. The problem there, I think, is that when I earlier was talking about the fact that IIIF is founded on simple web principles, and a IIIF resource is basically an assembly of web primitives in quite a complex way, we're not quite at the same stage with 3D on the web. I think we're nearly there, but we're not quite at the same stage where we could have a really obvious way of doing that in IIIF that was not going to maybe cause a slight problem in a year or two's time for some people. So, the kind of natural thing to do would be to extend the annotation space with a Z dimension. Our annotations are possibly cuboids rather than rectangles. But what we need to explore in experimentation, which is what the 3D working group is doing, is whether that kind of simple extension of the spatial model actually works for the 3D interoperability use cases. Because the 3D interoperability use cases are really fascinating. They are reassembly of archaeological sites, recombination of sculptures maybe in one place. All those things are fantastic. So we just need to make sure that we get it right, because we're being very conservative about how we define a space-time annotation space for these things to live in. We need to be really sure that 3D on the web fits into that space nicely. But yes, there is a 3D interest group in IIIF. So I'm going to, that's the end of my presentation, and we have 8 minutes left, so I will just take questions. The technology training room, the question about flavors was prompted by the Recogito annotation tool over the British Library Manifest, but reading the Bodleian Library Manifest. Yes, so I guess the IIIF specification is quite flexible and comprehensive. It may be the case that certain software applications are making assumptions about what is in a IIIF manifest that may not be entirely valid. There is a validator tool for manifests, but even if your manifest is valid, you're not obliged to provide every single feature. So a client needs to understand what is and what isn't present in a manifest. So a multi-purpose viewer like Mirador or the universal viewer has to be various, not necessarily flavors of specification, it's all the same specification, but there may be things in one manifest that aren't visible in another. There may be particular types of annotation that one viewer doesn't support because it just hasn't been developed to support that use case, and so on. So for example, search capability is a plugin in Mirador but built into the universal viewer. The universal viewer at the moment doesn't have the ability to display arbitrary annotations other than through search or through other experiments. But their kind of common baseline use cases are the same. Yeah, but in that case, it sounds like, so for the Recogito tool to be tripping over the British Library manifest, so either that manifest is invalid or the tool is expecting something in that manifest that is actually not required, but is maybe required by the Recogito tool. So, is it possible to combine different data types, multispectral captures, layered analytical data, microscopic images? Yes, absolutely. So the annotation space could be as complex as you like. So for example, we think about our multispectral use case we were looking at in the slide earlier, you could have a set of choices of multispectral layers as one annotation. So you can turn those layers on and off. You might have an annotation on one particular point on the canvas that links to a data set that may be a pigment analysis of that particular point on the canvas. You may have some commentary about that data set. You may have a description of a region of the canvas that point appears in. You can simply add all this stuff in, and I guess that's where some of the complexity of IIIF comes in. It may be the case that if you open that thing in the universal viewer, it wouldn't see any of that because it's not looking for it. But in a more tailored tool, you might see more of that additional content. But a project can use that kind of content for bespoke applications, because what the specification is doing is providing a standard linking mechanism no matter what's on either end of those links. So can you say a bit about using IIIF for content enrichment? Oh, sorry, I've missed one. What is the version 3 release schedule and how stable final is the current beta? So the intention is to release version 3 of the presentation API, which is currently release candidate 2 of beta, to release that by the time of the next IIIF conference, which is in Göttingen in June. But the current beta is extremely stable, I would say. It's, certainly the British Library are implementing against it and others are implementing against it. There are some minor details, some very, very minor details still to be ironed out. But I would, at this point, that specification is stable. There may be a couple of very small details you might need to change, but fundamentally that's a release candidate spec. Can you say a bit about content enrichment? So this is something that Digerati have been doing, especially on the Indigenous Digital Archive project, where the fact that our source material is available in this standard and the outputs of any additional processing we might do are also a standard, W3C Web Annotation Data Model. We've built a kind of text pipeline that begins with OCR and handwriting recognition, runs through natural language processing to apply named entity recognition to the text, and ends with the enriched material published as enhanced manifests that contain search services, links to transcriptions as annotations, links to tagging, annotation lists for entity tags, and so on. So I think this is a really exciting possibility, because it means that you can standardize the way in which you enrich content. And enrichment is both humans and machines, because enrichment could come through human crowdsourcing or through computational processes. But the way of assembling the outputs of enrichment, IIIF plus annotations gives us a standard way of doing that. can you say something about the server infrastructure needed for IIIF? So I guess there are two parts to that question. So focusing on today is the presentation API. And essentially, it kind of depends on where you're coming from. If you're a library that has a complex digitization workflow, your server infrastructure for serving the presentation API is likely to be a transformation step from formats like METs. But alongside that version, alongside that API, there is the image API, which provides those deep zoom features for images. And for that, you need specialist software called an image server. IIIF is not dependent on having an image server. You can have static images too. But that half of the infrastructure requires image servers, of which there are half a dozen or more open source implementations in various languages. Thank you very much for listening, and I hope you could see all that.